Assalamualaikum and hello everyone. We are from Group 5 and we are going to present our case study titled A Study of the 2024 Lahad Datu Earthquake Events. My name is Amni Afika Binti Zaini and I will start with the geological background of Lahad Datu. Lahad Datu is located in eastern Sabah, which is one of the most earthquake-active regions in Malaysia. This is because the area is close to three major tectonic plates, which are the Eurasian Plate, the Indo-Australian Plate, and the Philippine Sea Plate. The movement of these plates makes the ground in Sabah more active. The region is mainly affected by strong pressure from the west to east direction. This pressure causes the land to deform and leads to the formation of faults. Geologically, Lahad Datu is made up of old basement rocks that are covered by younger sedimentary rocks. These rock layers have been shaped over a long period of time by tectonic forces. Several active faults are found in and around Lahad Datu, especially strike slip and thrust faults. These faults allow the stress in the earth crust to be released during earthquakes. There are also visible surface features such as mud volcanoes, hot springs, fault scarps, and straight valleys. These features show that tectonic activity in the area is still ongoing. All of these geological conditions explain why earthquakes have occurred in Lahad Datu, including the major magnitude 6.2 earthquake in 1976.
Hello everyone, my name is Shelvina Lidis with the matrix number of BS23110049. So for my part, I will explain about the tectonic setting and seismic activity of the Lahad Datu area. Well, Sabah is tectonically active even though it is not located on a major plate boundary. This is because regional stress from the Eurasian, Indo-Australian, and Philippine Sea plates is transferred into Sabah Crust. In eastern Sabah, the dominant stress direction is from west-northwest to east-southeast, which control fault movement. As a result, earthquakes in Sabah are classified as intraplate earthquakes rather than subduction-related events. Seismic activity in Lahad Datu is mainly controlled by local active crustal faults. The dominant fault mechanism are strike slip and thrust faulting. Several important faults are involved, including the Lahad Datu, Tabin, Silam, Sakar, Bakapit, and Mensaban faults. Based on the data of 2019 to 2024, the evidence of ongoing tectonic activity is supported by GNSS, which is the short form for Global Navigation Satellite System. The data shows active crucial deformation with horizontal movement of about 4 to 15 millimeters and vertical uplift or subsidence of several millimeters. This deformation is driven by compression between the northeast and northwest Borneo Trough. The 2024 Lahad Datu earthquake events were shallow focus and moderate in magnitude, caused by reactivation of local faults rather than major plate motion. The presence of minor aftershocks indicates stress redistribution along this fault zone. Overall, this event follows Sabah's typical pattern of shallow intraplate seismicity. That's all from me, thank you.
I will now summarize the scientific findings presented on this poster. We reviewed 5 key studies that explain the seismic risk in Lahad Datu. First, looking at the 2017 de-aggregation study. This research highlights the double threat. Seismic hazard here isn't just from one source. It is affected by both nearby local faults and distant subduction zone. This means our building designs must be versatile enough to withstand both moderate local earthquakes and large distant ones. Second, the 2018 hazard assessment. This study confirms that the primary risk to Lahad Datu is actually caused by local active faults. These faults are capable of producing very strong ground shaking, officially classifying this area as high risk for infrastructure. Third, regarding the timing, the 2022 nowcasting study. Researchers calculated an earthquake potential score of roughly 97%. This implies the region is critically close to its next earthquake event. It shows there is a very high statistical chance of a magnitude 4.0 or larger event happening soon. Fourth, the geological cause. detailed in the 2017 Active Tectonic Study. Lahad Datu is being squeezed by compressional forces, where this creates stress that releases through strike slip and thrust fault, the same mechanism that caused the historic earthquakes in 1976 and 1984. Finally, the 2025 GNSS study. Satellite data provides hard evidence that the ground is currently moving up to 15 mm horizontally and 8 mm vertically. This confirms that the local faults are definitely still active. So in conclusion, the science is clear. The risk is real, active, and also immediate.
Hello everyone, for my part, I will be discussing the recent and historical earthquake event in Lahad Datu, Sabah. This section aims to show whether the 2024 Lahad Datu earthquake is an isolated incident or part of Sabah long-term seismic activity. Historically, Sabah has experienced low to moderate magnitude earthquakes over several decades. These earthquakes are generally shallow in depth and are related to crustal fault activity rather than major plate boundaries. Although earthquakes in Sabah are not very frequent, past records show that the region is not earthquake-free. A key event in Sabah's seismic history is the 2015 Ranau earthquake with a magnitude of 6.0, which is the strongest earthquake recorded in Malaysia. This event confirmed the presence of active fault system in Sabah and significantly changed the understanding of seismic hazard in the region. Since then, smaller earthquakes have continued to occur across Sabah, indicating ongoing tectonic stress. The 2024 earthquake in Lahad Datu occurred in eastern Sabah and was characterized by a shallow depth and moderate magnitude. This earthquake is interpreted to be caused by the reactivation of local fault due to intraplate tectonic stress. The presence of minor aftershocks suggests stress adjustment along the fault system, which is consistent with Sabah typical seismic behavior. In conclusion, the 2024 Lahad Datu earthquake is not an isolated event. Instead, it fits within the historical pattern of shallow, intraplate earthquake in Sabah, highlighting the importance of continuous seismic monitoring and disaster preparedness in the region.
Hello, today I will discuss about community risk and vulnerability to earthquake in Sabah, focusing on Lahad Datu and Ranau as well as recommendation for public preparedness. First and foremost, Lahad Datu is identified as a high-risk area with an earthquake potential score or EPS about 97%. This indicates that the area is very close to experiencing its next earthquake of magnitude 4.0 or greater. Similarly, Ranau also shows high seismic risk with an EPS of approximately 92%, highlighting the serious earthquake threat in this region. Next, earthquakes with magnitude of 4.0 and above are capable of causing structural damage, especially in Sabah, where many buildings are highly vulnerable. This vulnerability significantly increases the risk to people, infrastructure, and essential public facilities such as schools and hospitals. To reduce this risk, several public preparedness measures are recommended. First, building safety standards should be improved to ensure that houses, schools, and public buildings can withstand earthquake of magnitude 4.0 and above. Secondly, seismic monitoring systems should be strengthened so that earthquake and ground movement can be detected more quickly. Next, nowcasting and EPS values should be used to track how close Lahad Datu is to its next earthquake and to guide effective risk planning. Updating earthquake records and database will also help improve long-term hazard assessment. Finally, it is crucial to educate the public on earthquake safety, including evacuation procedures and emergency response, and to plan efficient emergency response system for high-risk areas such as Lahad Datu and Ranau. That's all from me. Thank you.